If you think SAT or ACT math is about being good at math, I need to reframe that for you right now. The students who score the highest on this section are not necessarily the best math students in their school. They are the students who learn to recognize patterns, specific, repeatable patterns that appear on virtually every single test. SAT math is not a math test, it's a pattern recognition test. Most students prepare for the SAT math the same way they prepare for a school exam. They review formulas, work practice problems across all topics, and hope the right ones show up. The problem is that the SAT math section pulls from a surprisingly narrow pool of often utterly unfamiliar concepts presented in deceptive word problem format and disguise them in a surprisingly wide variety of forms. Students sometimes spend 2 weeks reviewing trigonometry for the SAT. There will be approximately 1 to 2 trig questions on the entire test. Meanwhile, have done zero prep for word problem translation, which, unlike school, is basically every single math question. This is the preparation equivalent of packing for a beach vacation by bringing a parka made for northern Siberia. The issue is not knowledge. It's knowledge of what the test actually emphasizes. Over 25 years of tracking students' results and analyzing actual SAT and ACT tests, we've identified the question types that appear with the highest frequency and the specific ways they are disguised from test to test. And here's what's remarkable. Once a student learns to recognize these few key patterns, questions that used to feel impossible start to feel familiar. Not easy necessarily, but increasingly familiar. And familiar is manageable. Pattern 1, linear relationships. Linear equations, linear functions, slope-intercept form, and systems of 2 equations. This category accounts for roughly 30% of all SAT math questions. The key insight? The SAT almost never asks you to solve a complex linear equation from scratch. It asks you to interpret them. And like many facets of a diamond, the geek nerd test writers cleverly know how to keep students on their trembling toes and often throw them off by asking the same thing 100 different ways. What does the slope represent in context? What does the y-intercept mean? What value of x satisfies both equations? Is this a Desmos question? When you shift from solve this to interpret this, the approach changes completely and the difficulty drops dramatically. Pattern 2, word problem translation. This is the most common stumbling block we see, not because the math is hard, but because students get lost in the language before they ever reach the calculation. The test writers know that too much information leads to overthinking and stress, which are score killers. Furthermore, because of so much digital conditioning these days, students opt for head math, and to me, head math is dead math. The strategy? Stop to dissect the information in logical pieces or chunks. Write it down by translating each piece of the word problem puzzle into a mathematical form and function before doing any arithmetic at all. This makes it easier to see how the pieces fit together. Students who do this consistently reduce their word problem error rate by more than half. In most cases, within 2 or 3 weeks of deliberate practice. Pattern 3, quadratics and parabolas. This appears in various forms: factoring, translations, the quadratic form and formula, vertex form, interpreting parabola graphs. The SAT tests this category in clusters. If you see one quadratic question, you will likely see 2 or 3 more on the same tests. Mastering the 3 standard forms of a quadratic equation and knowing when to use each one is one of the highest return investments in the math SAT prep. Pattern 4, data interpretations, charts, tables, scatter plots, statistics, mean, median, mode, standard deviation, two-way frequency tables. This category is growing in emphasis on both the SAT and the ACT. The key skill here is not statistical knowledge. It is reading carefully and extracting what the question is asking, not what you assume it's asking. The data is never the trap. The question wording is. Here is what this looks like in practice. Instead of reviewing all of the SAT math, a student spends 1 week on linear relationships, 1 week on word problem translation, 1 week on quadratics, 1 week on data interpretation, 4 weeks, 4 patterns. Enormous score impact. This sounds almost too simple. Students often ask us, "That's it?" Yes, that's it. The complexity is in the execution, not the plan, which is honestly how most important things in life work. Subscribe. Next week, we're going into the reading section, which has its own completely different set of strategies and its own specific traps. And if you want a math diagnostic that shows exactly which of these patterns you're currently missing and a targeted plan to fix them, the link below is where that starts. See you in the next video.